Okay, so this is going to represent our notes for the 3.3 section, which is verifying trigonometric identities. So in some cases, this is called proving trigonometric identities. So what we're going to do is we're going to work on one side, work on the other, use some of the identities that we have, and do some substitutions. There's a little bit of, if you had geometry proofs in this, and there's a little bit of logic involved. So we're going to give you some ideas on how to do a couple. And work through them, yeah. So let's see if we can present this to you a little bit here. So guides to verify the identities. First of all, it says, here's some hints for you if you want to write these down or highlight them. You want to pick one side of the equation to work with. It says usually it's easier to start with one, with the more complicated side, and try to simplify it, okay, until it looks like the other one. Now it might come a point where you have to go to the other side then and do it. So I think that's important to work one side at a time if you want. Another key thing is going to make everything sine and cosine, because then you have the opportunity for things to cross divide and be reduced or be rewritten. So now there it says look for algebraic operations you can perform. Adding fractions we're going to look at. Square terms. Factor out something comes up. I don't know if you remember conjugates. Probably won't get into that too much. Obviously distribute things. Yeah, and this multiply by a clever form of 1 is basically common denominators, if we want to look at that. Okay. Look for trigonometric things you can, such as if there are squares of functions, think the Pythagorean properties. They do want to remind you that all of these, because they're reciprocals of each other, equals 1. Okay, so again, there's going to be a little bit of a problem-solving approach going on here. Remember that? It says keep looking at your answer. That's your goal. So keep the goal in mind. Remember that there will be more than one way to verify an identity. Don't quit, it says. All right, and when you finish, you can put QED at the end. All right, I don't know if you need to do that, but we'll check it off. We'll put a check mark when we're done. All right, so let's do this. I don't know, you probably had exposed to this at some point, proving an algebraic identity. So when you have something like this, okay, there's a couple of things, if you would look at this problem to start, that I would hope you would see. First thing is these squares. Whenever I see squares, one thing that I think I would do is I would try to factor it. So I'm not sure what your memory of that. That's something called the difference of two squares. So do you remember that that would be factored in x plus 1, x minus 1? Okay, all over x minus 1 for the first one. Then that would be subtracted again, difference of two squares again, x plus 1, x minus 1 over x plus 1 equals 2. Notice I can't do anything with the 2. Now, just a reminder here, these cross divide. Now remember, each one of these becomes 1 when you cross divide. It doesn't totally disappear in this case, it doesn't matter. So what would I be left with? I'd be left with x plus 1 minus, I'll put the parentheses here to have it be like that. So just remember your basic rules when you add and subtract, of course. If I run that through, the x's are going to go away, and I end up with 2, right? Because x minus x, and this right here becomes x, the minus, and the minus becomes a 2. And then check, I would have it. Okay, so that's an example of using some factoring to work your way through. Now, let's look at some trig things here then. So we'll do a couple of these and see. So the first one here looks like this, all right? Now, if you have this, all right, the most complicated side is hard to know. I guess it would be the side with the most stuff on it. So let's look at the left-hand side. One thing to do would be to take 1 over cosine squared beta, okay, and go, you know what that is? That is secant squared. This equals that. Now, once I get here, this is where using your paper or using your resources that will allow you to use to come up with it. I don't know if you remember this. We presented this to you in the last section, but this is an identity that is true. So what you would do is that is equal to tangent squared. So that one finishes pretty quick if you know this identity, okay, for that one. So that's one example. Again, we'll try to lead you to where those resources are. Let's look at example 3 when I prove this identity. Now this one, I don't have too much going here, all right? So when I don't see any identities, you can search your sheet, and I don't have anything to factor or anything like that. Probably the best way to do this one would be to make this sine and cosine, okay? So if we look at that then and break it all down, let's see if we remember, and then I think it works out. So what is tangent? Tangent is sine of x over cosine of x, plus cotangent is cosine of x over sine of x, equals secant, which is 1 over cosine x, times cosecant, which is 1 over sine of x. So in this case, we can do that. Now, in some cases, you could leave one side the same and try to bring it back together. My recommendation to you is make it all sines and cosines so we can go. So now, what can I do with this? Not too much. So when you have an addition, though, once I run out of steam, okay, I got to get a common denominator. Now, I don't know how you were taught to do this. Mr. Zinn used to teach the butterfly method, okay? But do you agree, I don't know how, I'll just go with this, I guess, is that the denominator has to be cosine x sine x to get a common denominator. And then the old school way to do it is, here's this, right? If the new denominator is cosine x sine x, what do I have to multiply by? I have to multiply by sine of x to get it. Okay, actually, let me do this then, maybe. Okay, so I have a sine x cosine x here. I'll write it this way just in case that other way was more confusing. Okay, I got to get a common denominator. So what's missing from this? A sine. So I multiply the top by sine. I get sine squared x. On the bottom over here, right, I have a sine. Here's my new one. What's missing? A cosine. I have to multiply top and bottom by cosine to make it work. I get that. All right. Now, again, one thing that you can sort of skip through is I'm going to leave the right-hand side alone until I come back to it. I don't know, do you remember this? Again, this comes into the idea that that is an identity that's equal to 1. So guess what this would turn out to be? It would be equal to this, which I think is equal to, again, commutative property doesn't matter, but if I make a match, equal to that. So that's a short example of changing everything to sine and cosine, getting a common denominator, and again, recognizing this identity right there. Okay? All right, now, if we look down here, let's try another one of those here for example 5. Okay, so example 5, if you look at this, now, there's a couple ways to approach this one. I guess to go with their premise that I would take the longer side, and anything that can be rewritten as sine and cosine, maybe do that, okay? So on the left-hand side here, if I take sine squared theta times cosine squared theta, do you recognize that secant is 1 over cosine theta? So if you're a chess player, that's working out a little bit better. And then this over here, okay, would equal 1 minus cosine squared theta. Okay, now, what works out pretty good there, right? Do you see this cross division? That makes life easier for me, so I got lucky. Now, what you end up with here is sine squared theta is equal to 1 minus cosine squared theta. Now, this goes back to, we have to emphasize some of these properties and Pythagorean properties with you. And again, you'd have to search your resources, or hopefully you do enough. I don't know. Do you remember that cosine squared plus sine squared equals 1? Therefore, 1 minus cosine squared would be sine squared. Okay? So again, we're going to try to prompt you to use some of that stuff, but we can't have it. All right, let's do one more here quick. Let's go down here to number 8. See if we can put that together. So for this one, okay, you can choose either side to work on. I always sort of lean to the left and see if I can get going, and then maybe go to the right and see what we have. All right, so for this side, I end up with 1 over sine theta minus sine theta. So what I'm going to do then is, that's not very satisfying. So on the right-hand side, I'm going to make sure there's not something over there. So I'm going to rewrite this as cosine theta over sine theta times cosine theta. Okay. So I have that. Now on the right-hand side, I'm going to multiply. So I get cosine squared theta over sine theta. That's pretty much all that's going to do. So let's go to the right-hand side. When you have a difference or a sum, we got to do a common denominator. Okay, so that common denominator is going to be sine. So I'm going to leave this as 1 over sine theta. Again, just to remind you, this has to be sine theta on the bottom. Well, this was really over 1 to start. So I multiplied the bottom by sine theta. That means I have to multiply the top by sine theta. So that's just common denominator. When I put it together, I get 1 minus sine squared theta over sine theta equals this. Now, this is the one identity we'd like you to know. 1 minus sine squared theta is cosine squared theta. And again, we'll keep reviewing that if we need it. Equals this. And once I get a match, I accept it. Okay, so that represents the notes we'd like you to come to class with prepped.